All right, so 5.4 mid-segment theorem. So these first three problems, or not first three, 3 through 9, I don't know why I said first three, say that GH, HJ, and JG are mid-segments of triangle DEF. And then they give us a triangle Alright, so that's all given information that they gave us. And then we're going to answer different questions about this based on that information. So number 4 says blank is parallel to DE. So I'm trying to find which side, and my picture is not drawn very well, so it doesn't look, I'm going to try to fix it. Doesn't look perfect, but it's close enough. Okay, now it looks a little better. So which segment is parallel to DE? Now they're not marked, but if we know they're mid-segments, then we know that it has to be true. Yep, GH. So if you're like writing them down with like the blank and then parallel to DE, you can either write it in the blank when you're doing your problems, or you can like write it to the side. Either way is fine. 6, GH is equal to blank. So we have to find this one. So GH and DE are the two things that we're looking at. So based on the theorem, we would know that GH is half of DE, while DE is 24. So GH is 1/2 of 24, which is 12. So GH is equal to 12. Eight, JH is equal to blank. All right, so because this is a mid-segment here, I know that it has to be JH is equal to half of DF. Now, all I know is DG, but this is splitting this value here. So I know then that this value here, GF, also has to be 8. So that means that DF in total is 16. So I would have 1/2 of 16 is JH, which is equal to 8. So JH is also 8. All right, another example kind of like this. We're going to have another triangle and then more information. We're going to answer several questions about it. So for 12 through 19, we have triangle ABC where L, M, and N are midpoints of the sides. So they're just giving us the same information that we had in the previous problem in a slightly different way. So if we went up here in this previous triangle, J, G, and H were the midpoints of the sides of those, which is why DG is equal to GF, because those have to be, if it's a midpoint, it has to split it in half. So I have another triangle here. This one, they give me the information a little bit of a different way. So I've got triangle ABC. And then L, N, and M. And then this time, rather than giving me like numbers on the triangle, they're showing me where things are congruent. So remember, if we have little tick marks, that tells us if there's like one tick mark on two different things, that tells us that those things are congruent. If there's two, it says that those things are congruent. So BN is congruent to NC. And then CM has 3, so it's congruent to AM, like that. So in a different way, they've given us the same information, so then I know that like LN, NM, and ML are all mid-segments of a triangle.
What is our test on chapter 5?
Couldn't tell you. Because I said before the test, we started class, that we might not have a test on this chapter. I said it's TBD. All right, 12. LM is parallel to blank. So what would LM be parallel to with this given piece of information? BC. Yep, BC. 14. If AC is equal to 20, then LN is equal to blank. Yep, 10. Now, mathematically, so we can see it, AC is 20. Then half of that value is this one. So LN is equal to 1/2 of AC. So that's how we get that. I don't write it all out, but.
Do we have to show that work when we're doing it, or?
I would suggest you do, because if you get it wrong, then there's no partial credit if you don't have any work, if you just put a number. I would at least like write the formula like this out.
Okay.
But if you have the right answer, then it doesn't really matter. But 16. If NC is equal to 9, then LM is equal to blank. Yep. So we know that BC is equal to 9 plus 9, because this is a midpoint, so that's 18. So then LM is half of BC, and so that's how we would get that value there. Now, those ones have been relatively easy, right? So far. All right, so we're going to get one that's just a little bit harder with using the same information. We're going to actually have to do a little bit of math to this one other than just cutting a number in half. So if MN is equal to x minus 1 and AB is equal to 6x minus 18, then AB is equal to blank. Okay? So obviously they're looking for a number here because they already told us an equation. So the first thing I would do is figure out what associates these two things, MN and AB. So what, ignoring the stuff, the x's and all of that, if I just said what formula relates MN and AB, what would you tell me?
MN is half of
Yep, so I would start with that. So MN is equal to 1/2 of AB. Now I would use substitution and I would plug in the x minus 1 and the 6x minus 18 for these things. So I've got x minus 1 is equal to 1/2 times 6x minus 18. I would distribute over here on the right. It's going to make your life easier. Okay, so I've got x minus 1 is equal to half of 6x would be 3x, and then half of negative 18 would be negative 9. And then yeah, you're just solving an equation. So I'm going to subtract 3x. So I get negative 2x, and I'm going to add the 1 is equal to negative 8. So I'll show this. So that's what I did in that step there in red. And then we just need to divide by negative 2. So, turning away. X is equal to positive 4. Now, am I done? No. That just tells me what x is equal to, but what I'm looking for is AB, so make sure we watch that kind of stuff. So AB is equal to 6 times 4 minus 18, so that's 24 minus 18, which is 6, and so that is what I was looking for, so AB is equal to 6. Questions on that one?
Oh, shoot.
Other things that these problems could ask you is to take the information that you have and that you've solved for and then find like the perimeter. So adding up all the outside area, or I don't want to say area, adding up all the values of the outside of your triangle to find the perimeter of the triangle. They also could ask you to find the perimeter of the inside triangle. So using the information that we solved for. So as you find things, it might be beneficial for you to like write them on here. So like ln was 10, lm was 9, and then obviously we'd have to find this one, but we'd have to, when you do the odd problems, you'd be able to figure out what this is, and then you could find the perimeter of this by adding up all of those sides. So just watch, it may be asking you for the big triangle, like ABC, or it could be asking you for the little triangle, LMN, in here to find the perimeter. Okay. So one other problem. 28. This is to find the perimeter, so we'll get to do an example of that here. So given that CD is equal to 14, GF is equal to 8, and GC is equal to 5, find the perimeter of triangle BCD. So they're going to give us a triangle of what this looks like so that, you know, we're not playing a guessing game here. So the big triangle is BCD. And then we have our little triangle inside. Which is GFE. And then they've marked things that are congruent. So BG is congruent to GC, CF is congruent to FD, and then DE is congruent to BE. Like that. So anytime I'm given like a triangle and then it gives me values, I'm going to go put those on my triangle so that I know where they go. And so that I can solve for what I'm ultimately trying to solve for. So CD is equal to 14, so that's this whole side over here. GF is equal to 8, so that's right here, and I'm going to end up using that to solve for BD. And then GC is equal to 5, so that's that value there. And then I'll use that to solve for the entire side, okay? So I need to finish solving for side BC and then for BD because I already have CD. So the perimeter would be to add up all of the sides there. So if GC is 5, then what is BG? 5. So then the whole side is 10. So that's the whole side there. Now if GF is 8, what would BD have to be, or how would I find that?
8 would, or GF would be half of BD, so you would times it by 2 and it would be 16.
Yep. So I can multiply this by 2. So 2 times 8 is equal to BD. So 16 is that value. So 16 is the whole piece here. And obviously, as we've seen, when it's written this way, we can also say, okay, well, hopefully you've noticed by now that whatever your mid-segment length is, that's what this is and that's what that is. And you can quickly add them up that way as well. So then to find the perimeter, I would have 10 plus 14 plus 16, and that is equal to 40. So that's my perimeter of the whole triangle. Now, just for the sake of having another one, or if they asked us to find the perimeter, let's do it this way. Find the perimeter. This is not what this question asks. I'm just having us do it. Of triangle EFG. All right, so I know GF. What about EF? What would that be equal to?
Is that a D or 5? 5.
Yep, 5. Because it's half of this, and so that's both of those are 5, so that one also is 5. And then what about GE? 7, yep, take half of that. And then we could just add those up. So the perimeter of that one would be 8 plus 5 plus 7, which is 20. So the perimeter of the little triangle is 20. The perimeter of the big triangle is 40. All right, any questions on that? Do y'all want to do the proofs with this chapter? I didn't think so. All right, then your problems for this stuff, you should have more than enough time to get them done because they're all this fast. 3 through 9 odd, 13 through 19 odd, 29, 47, 48, and 49. Now, 47, 48, and 49 are some review problems from stuff we did earlier in the chapter of like solving for the angles within the triangle to get you ready for the next section. Next section is still relatively easy as well, but it's to get you ready for that, so you may need to look back. But in the instructions for those problems, it tells you what section to refer to if you've forgotten how to do it, okay? But those aren't optional. Sometimes when I give review problems, people just don't do them. They are like part of the homework, but anyways, any questions? Okay. Yes.